Okay, in this video, I'm actually going to take the time to talk about dimensional analysis. Now, this is your least favorite method of trying to solve things, but it helps you keep in order the units and helps you know when to multiply and divide rather than have to think about it every single time. So in this case, I'm going to start with a volume of 185 centimeters cubed of iron. Okay? Now I know this doesn't really look like a unit of volume, but since it's that cubed part, oops, over here, a cubed part, that means that it's cubed into a volume shape. So it's taking up some sort of space. It's not two-dimensional, it's three-dimensional now. I have a density of iron of 7.78 grams per milliliter. I want to know how many atoms this volume of iron takes up. Now I have a certain progression that I have to understand. I'm trying to convert from volume to mass to moles to particles, or in other words, atoms. Now the first thing that may be concerning is that I have different units of volume. Centimeters cubed and milliliters. Well, lucky for us, 1 milliliter equals 1 centimeter cubed. So we actually don't have to worry about that because they're the same amount of volume. Okay, first things first, I want to convert this volume to mass. So I'm going to set my fraction and my ratio. I know this is my density, grams per milliliter, per 1 milliliter. I want to get rid of my volume, so I'm going to put 1 milliliter here. Now above the line is the grams, which is 7.87. Okay, this is my density rewritten so that my volume is canceling out my volume and leaving me with my mass. Okay? Also now I see that it's above the line, that means I'm multiplying by the 7.87. 185 times 8.8, 7.87. Then I'm going to go to my next conversion. Now my next conversion is between mass and moles. In order to convert between mass and moles, I need my molar mass. In this case, I need the molar mass of iron. I'm just going to look at the periodic table, and the periodic table tells me that it's 56 grams per mole, okay, per 1 mole. So my grams are here. That means I want to cancel out my grams. I don't want grams anymore. I want moles. So 1 mole goes above the line, 56 grams goes below the line. That's 56 grams of iron per 1 mole. My last conversion is between particles and moles. That means I need Avogadro's number, which states that 1 mole equals 6.02 times 10 to the 23 of anything. In this case, it's going to be 6.02 times 10 to the 23 atoms of iron. So since I want to get rid of my moles, I put 1 mole below the line. Above the line goes 6.02 times 10 to the 23. And in this case, it's atoms. I need to extend that line a little bit. It's a large number. Okay, now my problem is set up. Volume is canceled out. Mass is canceled out. Moles is canceled out. All I'm left with is atoms. Now the only reason I can say they're canceled out is because think about it this way. It's as if I have a line running through all my conversion factors. If I have my units on the opposite side of the lines, that means they're going to cancel out. So now in my calculator, all I need to type in is 185 times 7.87 divide by 65 times 6.02. And whatever that answer is left over, then at the end of it, I will write down 10 times 10 to the 23rd. So let's put this in our calculators. 185 times 7.87 divided by 56 times 6.02 equals. And in the end, we see that we have 156.5, and that's just rounding off, Now I told you I need to include my times 10 to the 23. And this is atoms. Now, if I don't want my decimal here, because I like to have my decimal between the first and the second unit, I'm actually going to move it 2 spaces. 1, 2. Now, since I moved it to the left, that's going to increase my exponent by 2. So that means I have 1.565 times 10 to the 25, and that's atoms, specifically of iron. And this is the correct answer for how many atoms I have in 185 cubic centimeters. Yeah, cubic centimeters of